Firstly, I'm honored to be here in front of you, talking to you about the cloud application journey with Helm and Kubernetes. Hope you'll enjoy my talk. And it's my first time here at Devoxx UK, so please be merciful with me. Firstly, I would like to introduce myself. I'm Ana. I'm a technical lead for projects related to marketing platforms in IBM Client Innovation Center, Romania. I also enjoy to help on topics related to IBM Cloud, not only marketing platforms. And my colleagues often ask me questions, and I have just made a summary of what they ask me. And they all start like, how would you do if? Or how would we do if? And they start just telling me a complex scenario on what they're planning to do, like requirements. And start thinking and analyzing, and most of the time coming up with solutions. And today's presentation is actually a small-scale solution that was provided to a colleague, of course. And I want to thank the colleague that he put me to think for this. And I also practice yoga. This is why I have the picture with me. So the question of today is, how would you do if you need to develop and deploy software at scale? And now this question sounds very, very important and very big. However, when people say this kind of question, they're thinking immediately to cloud, to containers, to Kubernetes, to Docker Swarm, all this good stuff. And they don't really think on how. And in today's presentation, we're going to put an accent on how. Firstly, the journey of today, we're going to speak about why Kubernetes and Helm. So why do we choose Kubernetes and Helm? How to Dockerize an application, because we need to start from some point. Then deploy that application, firstly using Kubernetes, simple Kubernetes deployment files, and then Helm deployments. And some takeaways, of course. Firstly, why Kubernetes and Helm? Well, as developers and operations, we have some concerns. We do tasks mostly, and sometimes those tasks require integration. We don't develop, all of us don't develop with the same programming language. We don't all use the same frameworks, even in Java. And sometimes doing this integration puts us into trouble. And when it comes to deploy those things, we kind of require a framework helping us, supporting us with primitives, being agnostic of our programming language. And this is where Kubernetes comes to help us. Then a lot of time we are doing swapping of configurations, even in our local host. Imagine when you're connecting to a database somewhere, and then you are just switching that configuration, or you're installing something in order to replicate something that happens somewhere else, or you're just installing something in order to have your environment set up. You're doing a lot of swaps of configurations. And this replicates also for the operation people, because they also have to port that configuration swapping when they are installing what you are coding. And they have to think very well to the good process isolation. Again, Kubernetes is very helpful with that. And then our favorite, the release, is that moment, the deadline, when we are all very, very clinched with developers and operations, and we're thinking, yes, we have to make it, we have to make it. Yet, we, most of the time, also think to what happens next. So the release is important, but we have also a plan on how we're going to make the maintenance after the release. Well, we want to be perfect, and we sustain we are perfect. However, some small bugs always come up, and we need to be able to intervene, to have an intervention there, and to do an easy way and an easy maintenance on how we're doing things. And this is where Kubernetes, together with Helm, is again helping us, both developers and operations. And then we want to evolve our application, because our application is not something static. It evolves in time. It has to be beautiful. It has to be greater. It has to be bigger. And then we are thinking in terms of portability, because we don't want to be binded to a certain environment. And this is, again, where Kubernetes is coming and help for us. And every time a new environment comes for us to be done, Kubernetes is there to support us with the multi-environment capabilities, while Helm, with its templates, is helping us to extend those multi-environment capabilities. Those being said, I would like to present you the development scenario of today. Oftentimes, when I go outside the country, and even inside the country, I buy books. I like to buy printed books. not just for myself. When I go outside the country to conferences, because I have a lot of tech friends, I buy books, especially from DevOps Belgium. I buy a lot of books, and I have some more time. I'm noting down those books, and I'm saying, so this book is for my friend X. This book is for my friend Y, and so on. And I thought, what do I do? Why do I do an application to manage this acquisition of books of mine? However, I made it with Spring Boot because it's easy, it's fast, it's there. Then I needed some persistency. So I thought of adding a database to persist my stuff. And I chose the Cloud on DB managed service because it was quite good on pricing. It comes with a good free layer. And then I thought of, but I want to make this portable because I said I want to be portable. And, containers, right? I want to Dockerize it. So I have to make a Docker image. Where do I push it? In a private image registry. So store it in a private image registry. But then I'm thinking, but I want to be portable also in terms of deployment and be agnostic in terms of where I'm putting my stuff. So I'm deploying in a Kubernetes cluster using Helm. So this is our entire scenario for today, what we're going to cover up in the next 44 minutes. And as prerequisites, of course, an IDE, platform as a service account with some Kubernetes cluster support because you need a Kubernetes cluster to deploy your stuff. A source code repository account because as good developers, we want to have a single source of truth where we put our code. And a container registry access. You can choose Docker Hub or, like me, a private image registry. kubectl command line and Helm installed on localhost, and I'm going to explain later on how to do with tiller and install it for the server side. So regarding Dockerizing the application, we have to first think of what are we Dockerizing, right? So this would be a simple idea of what are we Dockerizing. It's a simple application with Spring Boot application, 3 controllers, nothing much easier. It's not a lot of business happening there. It's not our main focus of today, it's how we are doing things. And this Spring Boot application, of course, I created a Dockerfile for it. So you can see here that I'm saying from base image tag. So I haven't given you a certain base image. And this is why, because you can get base images from multiple places. And you can choose from a lot of repositories. The key to that is to just Google official Java base Docker something on Google, and it'll give you some official Docker repositories where you can get some good stuff. I'm going to show you my Docker image when we're going to do the code where I've got mine. Then I'm adding my code because I want to say Docker, hey Docker, take my code, put it in this folder, and then I just want to build my stuff. And Spring Boot comes together with some Maven wrappers that are very helpful in terms of building my stuff with Maven. And I simply use the shell scripts that were given to me by Spring Boot. Or you can just have your own Maven wrappers because they're also open sourced from the internet. And created my war. Just simply set mwn clean package minus profile, whatever profile you're using. And then I just moved my code in app.war and started it. Nothing more simpler than that, so pretty easy and pretty standard. However, many of my colleagues also ask me, is this the only way we can do things? Well, the answer is no. There are many more options. And this is another way of doing things. And I have another way, and you can ask me also about the another way after the talk maybe, or in the questions session. So another way of creating Docker files is from Maven. So there is a Docker Hub repo where you get Maven together with a Java-based image, as in the previous example, whatever tag you like. And you just add your code and do your good stuff. The main difference now is that you're just running mvn clean package with your profile directly without any other shell scripts necessary to do that. So this is another way of doing if you're more Java-oriented and you just want to think in terms of Java commands. And then the entry point is simple java -jar app.war. So it's nothing very, very difficult. Then you're thinking in making this Docker image available. So everyone, I think, is aware of how to use Docker and Docker build, Docker push. This is main commands that you're using in order to build your Docker image, to push your image. However, this is very nice when you're just getting acquainted and you just want to warm up. But if you are interacting with the cloud, you can use whatever the cloud has given you. So in my case, I just use the commands bxcr build, and then I inspect the image that I've created. And then since I'm issuing many commands, either Docker build and Docker push, or the other two, with the interaction with the cloud, and I'm realizing as a developer that I'm kind of a lot of time issuing this in order to build my image, it's not very productive. So what I can do is to make scripts with those commands, and then just execute those scripts. Or if we are thinking in terms of a pipeline, those scripts can be sourced and executed by the pipeline. So this is how you're delegating responsibility of making a Docker image built and available to another third party or to another script. So you're not working a lot you're not issuing commands all the time and working a lot on that. And you're automating your work. Now, the good stuff about the Kubernetes and Helm deployment. Because now we saw the Docker image, how we're building it, how we're making it available, how we can push it to the cloud, and how we can put it in the Docker image registry. Let's talk about some Kubernetes concepts. Could you please raise your hands, those of you who are aware of Kubernetes, how is it looking like, the architecture and other stuff? Okay, so kind of half the room. It's good. So I'm going to go very quickly to this. So everyone knows that a Kubernetes cluster has a master node and worker nodes, right? So the master node is the brain of your cluster and is the one who controls what happens with the workers or even with itself. And the master node, it has several components that are helping you manage everything inside your cluster. So there's the etcd, where you store your configuration, so it's like a memory of the brain. There's the control manager, who is ensuring that the desired state of your nodes is matching the current one and is telling that to the API server all the time. And then is the scheduler, who is actually assigning workloads to the worker nodes and is able to schedule those workloads without affecting your things. So the API server, last but not least, is the translator who talks with the kubelets. And the kubelets are the ones that are receiving the instructions and putting things on the pods. The pods are just covering your Docker containers, and they're the ones who are exposing themselves through kubelet and through node later on. So those being said, we work with objects. And we work with deployments. Deployments which are updates in terms of primitives, and we are issuing those, and we're saying to Kubernetes, well, I want this amount of replica doing these things with this container image, and so on. And the replica sets are just ensuring that the right amount of pod replicas are running for you, while the service is exposing as a virtual endpoint an entrance to those pod replicas that you're having. And there are some actions you can do with the Kubernetes objects. You can create, you can update, you can roll back, you can scale up, clean up, and pause your deployments. So this is pretty neat. However, let's see some code now. So I'm already logged in the IBM Cloud. And the first thing that I want to do is just check what clusters do I have available. And I'm just going to issue bxcs clusters. Okay. And in order to work with my cluster, I'm just going to download it. Download its configuration. Set it up already. And then I need to check up, because in my scenario, I was telling you that, okay, I have an application deployed inside a cluster that communicates with a database that is outside the cluster. And somehow I have to make aware the application from inside of the service that is outside. So I have to bind it to my cluster. So first, I would like to see what services I have available in my space bx service list, and I will want to get some ID for this service. Bx service show book minus cloud.tont. Okay. And in order to bind my cluster to this service, I'm just going to issue bxcs cluster service bind. My cluster, the name of my cluster, a namespace where I want to bind it. I'm going to make the deploy, it's the default one, and the UID of the service. Oh. Thanks. Sorry. Thank you very much. So after binding it, I get a secret. And I get a response that I have binded the service to my cluster to the namespace default. And this secret is going to be used to make the handshake between my application and the database service. And the secret itself, it represents a file. And now let's go a little bit to the code of the application and see how do you work with this secret. First of all, in the application, you have to make it aware that you are having a secret at some kind of location. And in my resources file, I've specified a path to the secret where I'm going to mount this. And when I'm going to do the deployment, I am going to mount this and make it available at this path. And when everything is going to start, the application will read the contents of the secret. It will connect to the database and will communicate successfully with that one. So I have the path specified here. And in my app, I just simply injected it with that value. And I'm simply doing a file reading of the credentials and then making my cloud on client in terms of database. And if I want to test it on local machine, I just created a fake secret for me, running it like any other Spring Boot app. Okay, so it seems that everything worked fine. Good. Stop it. And let's go to the Kubernetes deployment part. So the my deployment.yml for Kubernetes, it should comprise two parts. A part where I am saying what application I am deploying, and the part saying the service, how am I accessing this application. So for the part of the application, the kind of deployment I'm doing is deployment. I'm specifying as metadata as the name of the application that I'm trying to deploy. Then a template for my deploy. And I have to do some container specifications for what I'm trying to deploy. So first, I'm going to do this. And I want to know the image that I want to deploy. So I'm just going to look in my private image registry and get this one for deployment. Okay, specify a name. Make the YML file correct. And then I see that I need to specify some volumes. So I need to mount my volumes to my container in order to see the path to that. So I'm specifying volume mounts. And I'm just giving it a name, service book bind. Then I am giving it a mount path to where I can find this secret. It's opt service minus bind. And then I realized that I have given the path, I've given a name for where I should find this, then I have to give the what I find. So the secret itself. So I'm putting myself the containers, I'm specifying volumes, giving it the same name as above, service minus book minus bind, in order to be found. And the secret, I'm going to give it a default mode for reading it, to specify for 20. And the secret name from the one generated previously, here. Okay, just one small error for me. It's not on the same level. Now it should be correct. Deleting this, it's not needed anymore. The node port, just put it on 22 or 52, just make it like this. And if I'm going to the command line, I just want to deploy this simply with kubectl apply -f deployment.yml. And I see that my deployment was configured, the service was configured, and then I want just to describe what I have just done, and I want to see how the service is doing. So I'm issuing the command kubectl describe services book -bmx -demo. And then if I want to see how my pod is feeling, I am just going to issue the command kubectl get pods -selector app book -bmx -demo. Okay, so it's running. Then I want to know the public IP that I'm running this, because I just deployed it on public IP and just want to access it. So I'm just going to issue the bxcs workers command to find out the address of my worker. I have only one worker. So this is my public IP. The port I'm expecting to find this service is this one. Copy. Oh, and it got deployed. Everything seems okay. Now, getting back to the presentation, again, we can automate our work through scripting, so I'm not going to issue these commands all the time. I'm just going to make a shell script and run it. And also, that could be used by the pipeline if I'm using a pipeline for building my stuff. However, there are some concerns. How do I manage multiple configurations this way? So now I have just a simple application, but how do I do it for many more? Do I do multiple deployment.yml files, and I'm thinking of maintaining all of these? There are also the problem of reuse. You want to be able to reuse such a deployment, and this is kind of connected to what image, what tag, and a lot of other stuff that you have just done for specifically for this application. And there's a problem with how can parameters be added to this application? I want to be more parameterizable, not just statically dependent on these values. So because of that, Helm, the package manager for Kubernetes, is used for better management of doing deployments with Kubernetes. And a little bit of introduction on Helm. A Helm chart represents metadata describing application and infrastructure, meaning there's this in terms of Kubernetes. And Helm charts represent a structure of a set of files having a package description, the chart.yml part, and a set of templates using Go template. A set of templates for Kubernetes manifest files. So they're offering us a patterned way of working with Kubernetes. Now, this is from the developer's perspective. This is what we're coding as developers. However, from operational perspective, there is the view of parts of Helm parts, the client and the tiller. The client is us, if you have Helm installed on our machine, and every time we're issuing Helm in the command line, we are the client. And the tiller is installed in the cloud or is installed on our local host if we're using Minikube. And there are some concepts and advantages that help us as developers in comparison to the previous type of deployment. So we have templates, and they allow us to control more, to have more granularity on each thing that we're doing on Kubernetes. We have values, so we're not scattering values anymore in each part of what we're doing in services, in deployment, and so on, in application description, and so on. We have requirements to have single orchestrations of complex deployments. So when there are needs for complex deployments and have them done in one shot, we can use the requirements file. And we have the terms of release. So every time we can follow what we are installing with Helm releases. And we are able to do this in a more standardized way. And we have the concept of repository to be able to share and reuse configurations. And the repository concept does not apply just to the published charts and the ones that are available public on GitHub. It applies also to our project. So using the Helm add repository command, we can specify user and a password, and we can make use of our own configuration of charts in our projects in order to have complex deployments and reuse for our stuff. So, again, a code break. So for Helm, first I would like to check if everything's okay, and I will issue Helm version. As a response, Helm version is going to tell me what client I have installed and what version is in the cloud. So the server part is the one from the cloud. If I wouldn't get a response from the server, like error type tiller not found, this means that either I am not connected to the cloud, so I don't have internet connection, or is the problem of, I don't know, I haven't downloaded the configuration of the cluster. It can happen out of rush. Also, then I want to create the charts for my application. So I'll issue Helm create book BMX demo. And as a result, I'm going to get an hierarchy of files created in my project. So I'm going here. Everything done. And there's chart.yml, the one that's containing the package description, what we're trying to install using Helm. And it has some default values, so Helm chart for book acquisition app. It has a version for the charts, a version for the app, and so on. And, of course, the name of the app. And there's the values part. So this is where we're going to populate all those static things that we were populating before in the deployment.yml. So we are tracing everything in one single file, not in a lot of places. And in values for my application, I would put again the values for me. So first I'm going to put the image-related part. And the repository that I am targeting is not this one. Just get one. I'm putting here the repository for my charts. I'm statically getting it. So I'm going to issue the command vxcr images -- quiet. Okay. There should be enough. The tag 1. The pull policy always, because when we're doing development, we keep on doing development and we are making improvements, we're making changes, and we want to always pull the Docker image to make sure we got the latest part. Secret to get the image. It's more safe to do that from the private image registry, the secret name that was previously used, and the volumes part. And also for the service part, we're defining the name, the type, and the internal port, and the node port where to put the service. So 31666. Just whatever. And for the deployment YML file, when you open it, we just see a lot of already completed stuff, and it looks different from the other one. It's templatized using Go language. It's very easy to follow and very easy to understand. It doesn't require a lot of work to understand this. And you're just simply replacing your stuff or putting your stuff with the values that you have declared before. So you're just using the labels of your values and you're putting them into your Helm charts. The deployment part contains the application that you're going to deploy. And here you're going to specify the part with, so what you're going to deploy in terms of containers. So for container part, I have to add a few things. For the volume mount, and I'm going to add the name. Just reading it from the values. So values.image.volumes.name. Image.volumes.name. And then I'm going to say mount path. .values.image.volumes, and I think it's mount path. Mount path. And container port is 8080. And mount the volumes for me. So just mounting the volumes with what's left. Here's the service bind volume. And the values.image.volumes.name. So everything is templatized. It's not containing any more static things, and whatever is static can be also taken and put into values and furthermore replaced. So you can reuse this with how many values.yml files you want per your environment. So this is part of the reusable idea for your app. And then you just have to define the part of the service. So for the service, you are using, okay, and then a node port. .values. .service. .node port. Everything seems to be replaced. And then we can go to the command line. And I'm just going to list my previous installments to see what I would like to upgrade. So with Helm, you have a few options of deploying things. You can either install and issue Helm install command. So the Helm install command is going to make a new release for you. It's like a new instance. Or if you already have developed something and you're just adding more code, enhancements, and so on, you're upgrading your stuff. So you're just issuing Helm upgrade -- install for, let's say, dev -book -bmx -demo release from the book bmx demo folder, and for the namespace dev for the deployment. Okay, so now it seems everything's okay. If I want to check how my release went, I'm just going to issue Helm status dev -book -bmx -demo. And I see that I'm getting some commands also to help me to find my release. However, I can also check the history of what I have done. Helm history. And get an entire history of what I've done. Oh, sorry, too fast. Helm history dev -book -bmx -demo. And you can see what happened, what failed, what was superseded, what was deployed, and so on. Since I'm deploying in the same worker, I'm expecting for my application to be found at port 3166. Yep. So this is for a simple deployment with Helm. However, if you have more complex stuff, I said to you that we can use requirements.yml and to make more complex deployments. So we use requirements.yml for making those deployments that require dependencies. And I also have this kind of sample for you in terms of requirements. So my requirements, it has a front end made with a different programming language, and a backend, my previous done application. And all I'm doing, I'm aggregating this in the requirements.yml, and when I am upgrading my stuff, I'm just telling to Helm to use the requirements, and he is installing step-by-step these for me. So the same pattern of doing things applies, with the only difference that I am referencing the repositories from my file. So this is where the charts part is very useful, because you can just copy-paste already had charts in your local part, and you can just put them there and reference there from the repository. However, if you have GitHub or Git accounts, you can just put the repository of your Git account with one amendment. Before doing that, you have to add the repository with the Helm repository add command, of course, with the user and a password. And this way, your Helm is going to be aware that he can use other repositories defined somewhere else and do the requirements. And another good practice is to just have your Helm charts in a separate repository for more isolation and describing what you're trying to deploy. So in terms of using requirements, just moving myself to the other project. Book note. Again, I'm going to list my deployments, because I have one for requirements, which has two parts, it ends with rec. So I'm going to issue Helm upgrade, ---- install, book -bmx -demo -rec. And I want to use the folder containing requirements for the namespace dev. Okay, and my front end should be here. It's not a very, very sophisticated front end. Okay, so one more thing that I have forgotten to mention you, with the Helm charts, you also get these nice notes files already created. So the notes files contain instructions. So you saw that in the command line, after I have done the installment, I got a few things said about what I have done. But also at the end, it was saying to me, get the application URL by running these commands. Well, these things are coming from this part. So you can instruct and give instructions to those that are installing this in the notes part. And you can make easier for them to find things by just iterating those things here. So you just making things, make those that are using the charts aware of where they can find what they have deployed in a much easier way. And you can create how many as you want here and do it. One more thing I wanted to mention to you, when you're using requirements, you are not using any more deployment and the template for deployment and for the service, because you are just wanting to delegate the responsibility to those dependencies that you are deploying with the requirements file. And this is what I wanted to tell you about the Helm installation part, getting back to the presentation. I just want to make a summary for you. I haven't covered the part with the configure tiler. So to configure tiler, you can do it from your local machine. Just state Helm init. Helm init command is going to initialize the client for you, but also the server side, the tiller for you in the cloud, if you are connected to a server, to a cluster in the cloud. You are doing deployment with Helm upgrade install or Helm install. And the nice part of the Helm upgrade install and Helm install is that you can also supersede what you had in your charts file by using the --set command, and you can just say more things when you are executing the command and override what you have in the values. You can deploy with dedicated values, and you can use a values part for each environment that you want to deploy and just specify the name of your environment, dev, SIT, whatever, staging. And of course, at the end, you check by issuing the command Helm status and the release name. Now, as takeaways for the talk, I would like to say to you that you should plan before bending your application architecture. So plan very well before trying to do Helm charts. Do not track your local secrets in your revision control. So if you're using, like me, local secrets in order to test that things are working okay for you, that the application would behave okay, and would be aware of what would be there in the deployment part, do not track those under revision control. Create a chart per code artifact that you are producing. So if you are producing multiple WAR files, each of those should have a description inside of, in terms of chart files in Helm charts. Manage your dependencies with the requirements.yml. So if you have dependencies, or if you're using in your dependencies already published charts, use requirements.yml. And manage your environments with the multiple values.yml files. Those being said, I would like to thank you for listening to me. And if you have any questions, we have like 9 minutes for questions. Thanks. Thank you for your support.